Welcome to Notes 3.3. So in our previous notes, we talked a bunch about what happened when we had two parallel lines cut by a transversal and what was true about the angle pairs that created. And this time we're going to talk about the converse of all of those postulates and theorems. And remember, a converse is where we flip-flop the if and the then. So all of our previous theorems and postulates started with if my lines are parallel. Well, now, because we're flip-flopping the if and then, all of my converses are going to end with then the lines are parallel. So these are all ways of proving that two lines are parallel. And the first one deals with our corresponding angles. And remember, corresponding angles are angles that are in the same position relative to the intersection of the transversal with the two parallel lines. And it says that if I have two lines that are cut by a transversal so that the corresponding angles are congruent, then the lines are, oops, I thought I had an eraser going. Then the lines are parallel. All right, my alternate interior angles converse, same thing. If I have two lines cut by a transversal and my alternate interior angles are congruent, then my lines must be parallel. And so you remember we had shortcut phrases for using in our proofs last time. Well, we have them for the converse too. So if you're trying to prove two lines parallel by the corresponding angles converse, you're going to write if corresponding angles congruent, then lines are parallel. All right. If my alt-int angles are congruent, then my lines are parallel. And you will never, in a proof, write corresponding angles converse, alternate interior angles converse. Okay, you're going to write the whole if-then statement, but you can abbreviate it like this. Continuing on, if I have the alternate exterior angles and they are congruent, then my lines must be parallel. And again, if I have my consecutive interior angles, and here's the slight difference, if my consecutive interior angles are supplementary, then my lines must be parallel. So all of these end with then lines are parallel. It's just this consecutive interior angles converse talks about the angles being supplementary, which makes sense because my consecutive interior angles theorem said that if my lines are parallel, then my consecutive interior angles were supplementary. So that makes sense. All right, and then we have this last theorem here, transitive property. Well, my transitive property is my if and then property. And so this says if this is parallel to that and that is parallel to that, then that is parallel to that. All right, so we've got a bunch of parallel going on here. And let's talk about the shorthand version of each of these. As you might expect, this one says if alt x angles are congruent, then my lines are parallel. And this one says if consec int angles are supplementary, so sup, then my lines are parallel. All right. So this asks us to find the value of x that would make A parallel to B, and what I have going on here are corresponding angles. So if corresponding angles are congruent, then A is parallel to B. So if they're going to be congruent, then they must be equal to each other. So I set 5x minus 7 equal to 98 and solve for x. And I get x equals 21. Okay, this one says look at angles 2 and 3. So 2 and 3. If 2 is congruent to 3, then it's basically asking us which lines are parallel. Well, 2 and 3 are alternate exterior angles. A is my transversal, which means that my other two lines must be the parallel lines. So then x is parallel to y. A huge part of this unit is going to be figuring out which lines are my parallel lines and which one's the transversal. So make sure you can identify it. I know it's the transversal because it forms part of each of these two angles, part of angle 2 and part of angle 3. So that's what makes A my transversal. All right, now we're about to do a bunch of easy proofs. So I would like you to fill in the reason and then come back and check to see if you got the right answer. So we're given that A is parallel to B, and we need to say that 1 is congruent to 3. What's the reason? Hit pause, write it down, come back and check. Okay, so you should have gotten corresponding angles are congruent if A is parallel to B, although I don't know why it's written that way. We probably should have written it the other way. If A is parallel to B, then corresponding angles are congruent. Good job. All right, we have A is parallel to B, that is our given, and we need to say that 2 is congruent to 7. Please fill in the blank and come back and check and see if you're right. Okay, so you should have gotten if parallel, then alt int angles are congruent. Moving on to our next proof. We're given that A is parallel to B, which tells us that 6 and 7 are supplementary for some reason, and therefore we know that the measure of angle 6 plus the measure of angle 7 equals 180. Please fill in these two reasons and come back and check when you've got them. Okay, so you should have gotten if A is parallel to B, then consecutive interior angles are supplementary. And then obviously if my consecutive interior angles are supplementary, then their sums are 180 degrees. That is a definition of supplementary angles. How'd you do? Good, I hope. We're going to do some more proofs. And our previous proofs all started with our lines being parallel. And now we don't start with that. We're given something to do with the angles, and we have to finish up with our lines are parallel. So that means we're going to be using the converses that we talked about at the beginning of this unit. All right, so in this first proof, I'm given that 6 is congruent to 8. Well, what kind of angles are 6 and 8? They are corresponding angles. And that means I have my corresponding angles converse. So if my corresponding angles are congruent, then my lines must be parallel. So you can either write then line's parallel, or you can write then A is parallel to B. Either one is fine by me. Moving on to our next proof, I want you to give me the reason this time, the reason why if 3 is congruent to 6, then A is parallel to B. So pause and come back when you have the answer. All right, so 3 and 6 are alternate interior angles. So if alt int angles are congruent, then A is parallel to B. Good job. Moving on, we have a little bit of a longer proof. Now, we're told that A is parallel to B. So again, we're beginning with parallel lines. And we have to prove that 5 is congruent to 4. Well, if you and I were writing this proof, we would know that 5 and 4 are alternate exterior angles. So if A is parallel to B, then alternate exterior angles are congruent. So we would go straight from this step to this step, two-step proof, and we're done. But obviously the person writing this proof was not as smart as you and I are. So they took many more steps to get there. So what I would like you to do is figure out why they did what they did. So please go ahead, fill all these in, and come back when you have the answers. So hit pause now. All right, so that was my given, obviously. A is parallel to B is my given, which means that 5 is congruent to 7. So if lines parallel, if parallel, then the angles that 5 and 7 are, they are corresponding angles. And then corresponding angles are congruent. All right, 4 and 7 are vertical angles. That's my vertical angles postulate, and it simply states that vertical angles are congruent. And then finally, 5 is congruent to 4. Well, as we discussed previously, that's true by alternate exterior angles, but we're not going to use that. We're going to figure out why they said 5 is congruent to 7 and 4 is congruent to 7 before they did that. So if 5 is congruent to 7 and 4 is congruent to 7, then 5 is congruent to 4. Well, that if and then tells me that we are dealing with the transitive property. So transitive property of angle congruence. Did you get all those right? If not, do you know why you didn't? If you answered no to both those questions, please be sure to ask me about it in class. All right, really long proof now. So our final that we end up with is that A is parallel to B. And I am not a huge fan of this proof, so we're going to work this together. And I think you'll start to see why I'm not a huge fan. All right, we're given that 1 and 4 is supplementary. So here's 1, here's 4. They're supplementary. They're not any kind of angle pair that we know of. So it's a good thing that we have been given that. All right, and then I'm told that the measure of angle 1 plus the measure of angle 4 is 180 degrees. Well, if they're supplementary, their measure is 180. That is the definition of supplementary angles. Okay, and then I'm told that the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Well, that's true. It's true because they are a linear pair, and linear pairs are supplementary. So I feel like there's something missing here. So I'm going to be sneaky, and I'm going to add in a 3a. I'll make this one 3b. So 3a is I'm going to write angle 3 and angle 4 are supplementary. Okay, and my reason for that is going to be the linear pair postulates, which tells me that if two angles are a linear pair, then they are supplementary. And then I can say their measures are 180 degrees, and again, that is my definition of supplementary angles. I don't feel like you can go straight to saying that their measures equal 180 degrees unless you've previously said that they are supplementary. All right, so now moving on, we now can say that the measure of angle 1 plus the measure of angle 4 equals the measure of angle 3 plus the measure of angle 4. Well, if they're both equal to 180, then they are equal to each other because we have substituted. So that is my substitution property of equality. I wouldn't be totally opposed to the transitive property, but my general rule of thumb is that if I'm dealing with equality, I'm going to talk substitution, and if I'm dealing with congruency, I'm going to talk transitive. All right, then we make this very weird statement. So we say that the measure of angle 4 equals itself. Remember way back in Unit 2 when we learned our congruency properties, and I said this one doesn't make a whole lot of sense, but you'll need it at some point? Well, this is where we need it. This is my duh property. It is my reflexive property. And in this case, we're using it with an equality. The reason why I have to say this is because I am getting ready to go from this statement to this statement. And what happens is I get rid of the measure of angle 4 from both sides by subtraction. And in order to subtract that, I have to say that it is equal to itself first. It's sort of a nitpicky rule that we use in proofs. And the sooner you just accept it, the better off you will be. All right, so I just told you what happened between here and here that we subtracted. So that is my subtraction property of equality. And one thing I want to point out is notice how I wrote subst when I abbreviated and I wrote subtraction property of equality, because if you just write SUB prop of equality, well, both of these are the SUB prop of equality, and I don't know if you know which one it is. So I'm going to assume that you think it's the wrong one, and I'm going to mark it wrong because I'm evil. So make sure that you tell me specifically, I'm using substitution here, I'm using subtraction here. All right, and then how do we get from this step to this step? Well, if two measures are equal, then two angles are congruent. That is my definition of, and we're going to go with angle congruency, definition of angle congruence. All right, so angle 1 and angle 3 are congruent, which now allows me to say that A is parallel to B. What kind of angles are 1 and 3? They are corresponding. So if my corresponding angles are congruent, then my lines must be parallel. Yay, we did a long proof. Good for us. And only one little weird thing happened. So now that we are masters of proving lines parallel, we're going to stop our notes here. And I will see you in class to do lots more proofs. I'm looking forward to it. Thanks.